Okay, so today I want to talk a little bit about how can we leverage internet as your most safest enterprise network. And there are a lot of complexity with that. You think the internet is unsafe, but there are a lot of ways to make it much safer. And this is what I want to talk about today. So first of all, the traditional network in an enterprise is becoming a challenge, right? The perimeter has changed and it's no longer safe. It's actually not safe to glue all your networks together and have like a wide open network inside and assume that everyone inside your network is actually to be trusted. So a lot of things are changing, right? We have, for example, is a Gartner study allow the hybrid workspace, so more and more devices working from home, working from the office. How can we make policies universal against all users? We're using a hybrid cloud, so you have applications on-prem, you have them in Amazon, you might have them in Azure, in Google. So they are everywhere, so we need to glue all those networks together today to keep our network safe, and that's not the right way to do it either. We have more and more devices connecting to it, even non-corporate devices, so how do we manage that? We have a lot more cyber attacks. Once they're successful, they cause a lot of damage. And the last thing is, of course, is that a lot of things are created by humans by browsing to somewhere else, getting malware inside your laptop. And once the laptop is connected to your enterprise network, there's a lot of challenges to that, right? So that's what we're trying to solve. And if you look at the way we're going to do that, we're going to try to make a new perimeter, a new way of doing that. And that's called the people are the new perimeter, and it's software-defined perimeter, basically, what I'm going to talk about today. So in the old days, you have like a protected network, and they can be stretched across different data centers and stuff like that. But you're trying to build a fortress around your applications, and there might be only a few applications that users need to be able to access. And then, of course, everything, if you connect from the outside, needs a server, a listening port, or an available protocol to talk to. And today, these users are not only in the office, but they're also working from home. So how do you connect from home to a VPN? Inside the office, you use typically a NAC or a wireless management to get these people accessed. And once you're inside the network, you have access to most of the things in the network. It's actually over entitlement. A lot of issues happening there. So we need to make sure that we can reduce the attack surface in this case. So how do we do that? We're going to take that user outside the network. It doesn't need to belong inside the enterprise network. And we're actually going to put them on basically plain internet access. So the user is outside the network, and we try to build a fortress around most of your applications. This one might be on-prem, this might be in Google, this might be in Amazon, but we're trying to build a fortress around the applications and keep the user outside the network. That's what we're trying to do with this approach. So the biggest problem right now we're solving is that we have a fortress around it, so you don't have access to all applications. And we adapt the policy according to what the user you are, what device you're using, and those kind of things. That's the way we do it. And we're using standard internet cafe-style network for accessing those things. Of course, you say, hey, but the internet is not safe. You're crazy actually to build the things around your internet. And what are the issues with internet? The internet is basically a lot of open ports, and each port says, hey, I'm this SSH server, or I'm this VPN server, and you can actually look up and very easily find all these open ports. They're vulnerable for zero-day attacks. They are a lot of well-known vulnerabilities that if you don't patch your system on the internet, they will get compromised. And you can also have denial of service, people attacking them with a lot of packets and basically bringing down your service, right? So you need a few elements to work around these things. And the reason why it's becoming more and more important is this was an example from last year when Microsoft announced their zero-day vulnerability in Exchange server. It took only 5 minutes before the Hafnium hacking group became for first vulnerability. So even if you are patched on the internet, if there's a new vulnerability coming out, you don't have much time to fix those things. So what are we doing with Appgate to make sure that the internet is becoming safe? And that's basically a couple of things we're dealing with. And the first thing is what we're trying to do is we're coming up with a software-defined perimeter architecture. And the couple of things around that is, first of all, it's an identity-centric solution. So everything is around the identity. So you need to be authenticated before you can access anything else. We make sure that the authentication is done. We make sure that we only give you access to the application that you have access to. Everything else is invisible. And uttermost resources are completely invisible on the internet. And I mean invisible. It's like they're turned off. And secure, we basically secure hybrid and cloud environments. So it's a completely distributed software. and it's completely programmable and adaptable. So we can actually make things like only give you access when you have an open ticket, only give you access if you are an engineer and you want access to engineering assets in Amazon or tagged engineer. We can build that. And because we're using the internet, one of the things we need to make sure is we need to make those things invisible. And how do we do that? Is basically we can protect them by gateways that are invisible on the internet. And we use a concept called single packet authorization, which is a protocol that's kind of a port knocking that makes this server invisible. It doesn't answer to any TCP or UDP packet. It's completely dark. So you can try to ping it, hack it, zero-day attacks. They will not work. You need a valid key and a time-based token to ping on a UDP port before we open the TLS port. So it's actually completely dark, so no vulnerabilities, no scanning possible. They're all completely invisible in this case. Once the user is authenticated, it can actually make sure that you can actually authenticate to that server and make a connection to the sub-production server over the internet. How does it work? We have a couple of components, a client, a controller, and a gateway. The controller has like the brains and the policies. The client is basically what is who wants to connect, and the gateways are basically protecting all the applications, and you can have as many gateways as you want in the internet. So the way that works is, first step is we're going to make these things invisible, right? So they cannot be seen, they cannot be hacked. They are just using the internet, but we can actually protect them against DDoS because they're invisible. Even if you fire 1 million packets per second at it, we can just easily ping with the right packet, and it actually will open up the TCP port for me. Once we authenticate using our identity provider, we get like a high-level policy, and the policy are descriptive. They can be things like give access to the tickets, I open tickets that I have on ServiceNow, give me access to Amazon instances that are tagged for engineering as I'm an engineer, and if those things change, we can dynamically give access. So you get those tokens back. Those tokens are sent back to the client in this case, and now we're using another single packet authorization packet to open up the necessary gateways. We will translate those live entitlements into my personal firewall rule, and at the very last moment, I will build my own network. And now I have my network that's only unique to me, and I only will see that specific server that I need to get access to in this case, which is a server I want to get access to. So that's how it works, and that's how basically we make the internet safe and make sure that they cannot be seen on the internet in this case. So from a legacy perspective and perimeter based, you have all these interconnections. You have a VPN constater and VPN gateways everywhere, but you can actually do lateral movement. Once you're in a single entry, you can use MPLS or other networks to basically access everything. In our case, the user is central, and in my office and everywhere else, I just use standard internet. I use these single packet authorizations, and I make a direct connection to all of these different data centers at once. And that's how I make a safe perimeter. Most customers save about 80% of their MPLS and site-to-site VPNs. They do significant savings on office security because you just need a wireless guest network in this case. And the hackers are completely invisible for all these gateways because they are actually protected by the single packet authorization in this case. So today's business requirements are access to multiple clouds and hybrid environments. Which what can we solve? We can put like gateways everywhere. We actually need to access to dynamic environments where things are changing rapidly. I spin up a container for a few seconds or a few hours. I want to access it. It's possible. Once the container is gone, access is gone. If I spin up instances into my cloud, if the instances are gone, access is gone. I have control-tied business-to-business process. If I want to enable a new thing, I can actually do like a workflow automation. I can use open tickets. I can use my CMDB in this case for making sure the policies automatically fit. Access is driven by identity attributes, so I can take things like on the user elements like group membership, office location. I can take things from my device like my CrowdStrike risk score. I can take the operating systems, whatever you want. And I can use access anything from anywhere with the same policies. There is no difference between an on-prem user and a remote user. It's always the same. Maybe I see different things when I'm in the office versus somewhere else, but it's a single policy, so it's a lot more easier to manage my enterprise access in this case. So that's what I wanted to show you. A very quick summary of what software-defined perimeter can do. If you want to know a little bit more, ask my colleagues here to give you a short presentation how it works. How can we make things using internet and still be safe? And how can we basically avoid doing lateral movement and make your perimeter safe by using an individual perimeter and not like an enterprise-driven perimeter. So I hope you enjoyed it, and feel free to ask more questions to my colleagues over here. Thanks.